Hello and welcome. We are going to be recording a video with some Purescript again. So let's get started. We'll try to build an in-memory database or key value store, right? So what was the basic idea? Well, you have a key and a value, both will be strings, and you can store values at specific keys, and then you can retrieve them. And well, that's about it. It's going to be very, very simple, right? Right, so let's see. It's going to be a CLI application running Godnode, which means that there's no authentication. You can run any sort of commands. You can do anything you want, basically, right? It's not going to be anything using network right now. We will build these things later. So let's see, what kind of commands will we be able to run? Well, we can do put key and value, right? Which will add a value on the store using the specific key. And then if the key already exists, then we will override the value. Okay, then we have get key to read the value at a specific key. And then we have we should be able to dump all the values, all the keys and values, and exit to quit the application. Okay, cool. So let's see, what kind of things do we what are the kind of things that we need to build here, right, to make this work? Well, we need to have a list of commands, right? Basically a data type which represents the commands that we can run, right? We need a way to interpret, right? Basically evaluate commands and to do something on the database, I guess. Then we need to parse, right? Parse from string to command. And we need to do console input and output, right? So let's get started, right? So we're starting with the main. So we already created the project with Spago in it. We have done nothing more than just creating the project. And the plan is to write everything in this single file, right? We won't split anything in modules because it should be a pretty simple project. So let's start with defining the command, right? What's a command? Well, we start with creating a new data type, as we oftentimes do in Purescript. So we do a data command. Then we'll do equals, and then let's see what kind of commands can we have, right? Well, we can just look here, right? It's one of the commands is put, right? So you can do put as the name of the command, and then we can look at, okay, what kind of arguments does a put command have? Well, it has a key and a value, right? So we can probably just use two strings here, one representing the key and the other representing the value. And that's it, that's our first command. Another command is get, right? So we have get and then a string for keys. Again, very, very simple stuff. And then we have two commands that take no arguments. We have dump and we have exit, right? And we are done. It's that easy. This data type precisely represents all of our commands. We could obviously think about improving this by adding a new type here, like making this more type safe, right? Just making sure that we cannot confuse keys with values, and then maybe making values maybe we want to have integers as value as well as strings or anything else or something like that, but we will not worry about that right now. We will do that at some later date. Okay, so actually it's that easy. We are done with the first part, right? This is done, so we can go to interpreting commands. So what does interpreting a command is? Well, in order to answer this question, we kind of need to think about how we represent our database and how we run commands over it, right? So what would be the easiest way to represent our database? Well, probably the simplest way to represent our database would be having a map from string to string, essentially, right? That could be one solution to this problem. Another solution would be we could even make a function or like we could represent maps in different ways. You could use a list or an array of tuples. So we have to figure out what sort of store we want to do, right? So we could do something like data store equals to let's see, what kind of thing do we want, what kind of representation do we want to have for our data store. We could just try to use like do an array of tuple where we use string and string, right, as the two values. That should be good enough for our store, right? And we need to give it a constructor name, so it's store of this thing, right? I guess we can make it a new type since it has only one constructor. Okay, so this is how we store our database, right? This is our database or our store. So what is a how do we interpret a command, right? Well, let's write an interpret function. So what are the inputs? Well, obviously we need to get a command as an input because that's what we're interpreting. Then we need to get a store, right? Because we are operating over a store, right? So we need to do a store. But what's the result? Well, the result is one of two things, right? We are either doing some operation over the store, right? We are, well, for put, for example, we need to change the store, right? So we need to return the store in some way, shape, or form, right? Like a new store, because we don't get to mutate things in Purescript, so we need to return a new store, which is the old store plus this put command executed. And then if once that is figured out, let's see the next one, get. Well, in case of get, we need to basically print something out of the console. In case of dump, we also need to print something over the console, and then in case of exit, we need to exit the application, right? All of these things are effects, right? Which means that we need to run under the effect right? Because that's what it takes its name from, right? So that's our interpret type, right? So let's try implementing interpret. Right, so we have a command and a store. So what can we do with, like, what do we do here? There's only one thing that makes sense, right? We do a pattern match on command, right? So basically we're basically saying, okay, sorry about that. So we're basically saying, okay, let's do a case by case analysis on commands and then figure out what to do in each case, right? It's kind of a switch. So if we have a put with a key and a value, then what we need to do is basically update the store, right? Add a key. So maybe instead of writing the code inside here, we can just write a helper function to do that for us, right? This operation does not require any effect, so we are not, since we're not running an effect, we just do pure, like a pure value, not an effectful operation where we do update store key value store, right? And we will write this function later. We don't really care. Actually, we can, well, no, we will write this later. Then we have a get key command, right? So the get key command is an effectful operation because we need to console log this, right? So we'll do log of what? Well, get, again, we'll use a helper function here because we don't want to overcomplicate this this interpreter, right? So we will log a what? A function, well, the result of finding the key in the store, right? That's all we need to do. And then what else? We have dump, right? In which we will just log over all of the data in the store. So in this case, we could actually just, since array and tuple are, we can already show them, we could just show the whole structure, right? By just unwrapping this store constructor. That's one idea, or we could print it in a prettier way, right? Which is probably more the more elegant thing to do, right? So you could have a function that goes from a store to a list of strings, And then we could log each string on its own line, right? So in order to do that, we need to map the log function over a function which gives over the result, which should be something like, well, it's not actually a log, it's a traverse, right? Actually, should we make this simpler or not is the question. So what do we want to do? I think traverse is fine, although I think we need to include an extra library for traverse. So let's see what is traverse and where can we find it. So we're looking at Pursuit, which is the website which has all the functions in Purescript, and we can see what you can even see a very good like a very similar example here, right, in the documentation of traverse, right? You can traverse print or log, which are similar functions, over a list of things, and then you'll get each thing printed as a result, right? And this is in the it's in the foldable traversable package, so we need to import this package, right? So let's import that before continuing, just so we don't forget. So we need to go into the spago doll file, and we need to add foldable traversable. Let's actually reformat this to be a bit easier to read. Okay, and then let's add the library that we need to add after this one. So it's foldable traversable. I think we also need tuples for the tuple, right? We need tuples, yep. Okay, so let's quit and then let's do a, let's save. And let's do a spago install just to grab the dependencies that we were missing. And then do a build. And I guess we'll be getting an error on our code because we have not implemented a few functions, so that's definitely expected. So let's check out. So let's get this thing packs. Okay. And now we can do dump, right? So dump is literally traverse, the underscore version. So it's traverse of log over the store, which is the unwrapped, well, no, the get keys store, I guess. Should we just get the keys rather than everything, or get well, let's do get data, and we'll figure out how we write this function later. And then we have an exit, which should be a function which exits, right? So let's see what kind of let's see if we can easily find the function which exits the current program using. This might actually not be as simple as because this is not something that's often, and it's a very not something that you want to do often, and it's let's see, maybe we can search by exit. Yeah, so again, I guess we need to add one more yeah, we need node process in order to exit, so we need one more dependency for this. So it's node process, right? Okay, so we need to do what am I doing? Okay, spago install again and build. Building a couple of dependencies. Okay, and now we can do this. We can resume, right? So we open up main and readme, and let's see. We needed to do an exit, right? Like 0 is fine, right? And that's all we need to do. Right, so now the compiler is complaining about a few things. It doesn't know what tuple is because we tried using tuple before we had it imported, and then we didn't get the nice autocomplete which suggested us to add the import, right? So as I add this here, you should have you might have noticed that this line was added, right, by the IDE. Okay, so now this is correct, and now obviously it's complaining that we don't have a like update store function, right? So we need to start implementing this. So update store is a function which takes a string, which is the key, another string, which is the value, and then a store, and then it returns a store, right? So update store. Well, actually, I think our type isn't quite correct right now. We need to do some more things here and here because we are not correctly returning a store, right? We need to return the previous store here, but we'll get to that in a minute. Let's just handle the errors one by one, right? So we have key, value, and then let's unwrap the store, right? So store, if we do this, so this kind of syntax is pattern matching. And when you write this, basically, this is a store, but when you pattern match using the constructor, then the store variable, let's call it db instead, is literally an array of tuple string, right? Okay, so when we want to update this, so what do we want to do? Well, we basically want to go through this array one by one. We want to find the, well, actually, now that I think about it, I think maybe a list would be better suited than an array, because we never look by index, right? No, I don't think we have a way to clear a key asset, but we can write the code for that later. We can add a few more commands. So I think a list would be better suited, right? Because we don't actually, and no, get never doesn't always return a result. We'll figure this later as we go on. This was just the first pass, right? We'll definitely figure out, and we'll be using types to guide us into understanding why we have done the wrong thing here. And we'll fix it. So let's see. First thing, I think a list is better because we never want to use, like we won't not be indexing things, so it's a lot easier to work with lists. Right. So you have a list of tuple strings, okay. And that's inside the database, right? Okay, cool. So what do we want to do here? Well, we want to iterate over the list until we find the key that we're looking for. And if, well, when we find it, we want to basically override it, and if we never find it, then we add it to the end of the list, right? So what we need to do is basically we need to pattern match over database, right? So again, case db off, right? And then there are two ways to construct a list, right? One of them is nil, right? So a nil list is an empty list. So in case we have an empty list, then what do we do with? Well, we do a const, right? We append. So what do we append? Well, we append a tuple of key and value over the existing database, right? And of course, since we need to return a store, we need to add the store constructor on top of this. And then if we have a cons, right, where we have an x, which is the, well, we have a tuple, right? So we have a tuple with a key and a value. And we don't really care about the existing value, but this is the current key, let's call it, right? And then we have a rest of the list, right? So in this case, what do you want to do? Well, there are two options here. So let's do an if, right? Because that's the easiest thing we can do. So if current key is the same as the key we're looking for, then we need to we just replace the value, right? So we can basically say cons of tuple key and then the new value, right? We've replaced the value with the rest of the list, and then we throw everything into a store, right? And that's it. Also, if we have not found the thing, then we need to keep looking. So how do we keep looking? Well, that usually means a recursive call, right? So it's update store, where we with key, value, and instead of the rest is a list of tuple string, right? So we need to do store of rest just to wrap it again into the store type. And then the result is correct, right? Because the result is a store anyway. But the problem here is if we do this, we'll be losing the head of the list, like this thing. So we essentially need to somehow combine these stores together, right? So there are a few ways we can do that. One way is to just do it in line here. So we could do something like case this of store db. Well, let's do db prime. Then we need to do something like store of cons tuple current key and current value. Let's do some new lines here. Okay. Value and the db prime rest thing. Okay. And then we need a current value here. And then, okay, misspelled here. Oh yeah, and we need to also import the constructor here. Okay, I think this code could probably be a lot easier if instead of a new type we use that type. So maybe let's do that and just showcase that this code is extra safe like this, but we don't really need this right now. So let's do this thing then and make it a lot easier. So we don't need this. So let me waltz to this through this for a second, and then this can basically just be head at instead and do head well cons head and then update store key value rest, I think. Wait, is this not a thing? Okay, never mind, doesn't matter. We can do value here. I don't think we can call this key actually. Wait, never mind, that's fine. Key value, this is correct actually. And then we need to do wait, I think this is where I went to type head. Right, and then we don't need this anymore. Right, so let's review this right now, right? So since this is no longer a new type and it's just a type alias, then this is a lot simpler, right? Because we basically pattern match on the list directly. If it's nil, then we can basically just add the well, I think we just need nil here, right? So we basically return a, like, this means our database is empty. So if it's empty, we just add this key and value and then on top of the empty database. And then otherwise, if we have some key and then some rest of the list, right, some more values there, but like the top value is some key, then if the current key is the same as the old key, then we basically replace it and then build up with the rest of the list, right? Because we don't want to drop the rest of the database. And otherwise, then we have to keep the current head, which is whatever key value pair already exists there, and then iterate, like recurse inside the database. Okay, so then find key should be some function from string to store to well, to a string, right? We need to find that thing, right? So find key is basically looking for a key in the store. Let's call it database as well. Actually, it's store. Okay, that's fine. So again, pattern matching should be the simple thing to do here. So k store of. So if it's nil, then we simply, so if we've reached, so what does this mean? We've reached the end of the database and we have not found any key. So I guess here, like it's fine if we just, okay, so there are two things here. We might want to, like, the simplest thing could be like no key found, right? And that's fine. And this is actually correct and like reasonable because we know we cannot have spaces as either strings or values. I think I wrote that somewhere. Yeah, no spaces allowed, right? Just to make the parsing easier. So if we return something which has spaces, then we actually know that this is an error. As opposed, you can never have a value with this, right? Because it has spaces. So that this is fine for now. And then later, when we make this more complicated, we might have proper error handling. But for now, this is fine. Okay, Okay, so if we have some cons where we have some tuple of key, well, current key and some current value, well, I guess value will do, right? Because we don't have any other value. And then some value and then a rest of the list, then what do we do? Well, if, again, the same kind of thing, right? So if current key is key, then I guess we just return value, right? Else we iterate further, right? So it's find key, key, and then rest, right? That's pretty much everything we need to do. Okay, cool. So what's next? Well, it's get data. So what's get data? Well, so whenever we see this traverse log get data, then we can assume that this get data needs to be a string or something that we can log, right? I guess this means it's like an array or a list of strings, right? So let's say it's a, I don't know, list of strings. That's fine. So that means we basically need to go from store to list of string, right? Okay, so I guess we just need to pattern match, right? So case store of, again, yeah, like you'll see, this is a common concept here. What do? Well, we pattern match. That's what you oftentimes do when doing functional programming. So okay, if we've reached the end of the database, then we return an empty list, right? So they're basically going from a list of 2 strings to a list of a single string, right? So empty is the same as empty, and then cons of tuple, key, value, and rest is, well, again, we need to do a cons, right? Because nil goes to nil, cons goes to cons, right? But instead of 2 strings, we need a single string, right? So what's the string we want to build? Where we have a key, right? And then we need to do maybe something like maybe we could like, since we know we can't have spaces, we can do this thing, right? So key, arrow, value, right? Maybe fat arrow for whatever reason, right? And then value, and this operator is just string concatenation, right? It's we can do string concatenation using this operator. So we build, like, we have this value, and then what's the rest? Well, the rest is just get data on rest, right? We recursively call this function, and then we basically create this whole thing. Okay, so what's the error here? Okay, right, so now the error here is basically, okay, you, like, this function promises to return a store, right? But then log, and these 2 lines, like both of these, and you'll see if we fix the error, like if we swap the order, we'll get the error on this line, right? So we basically have the same error in both cases. Like when we log or when we traverse log, which is kind of the same thing, we basically get a single like we get a unit rather than a store back, right? So we kind of want to say, okay, log this, and after that return, give me back the original store, because we're not changing the store at all, right? So the simplest thing to do here is just using do syntax and then do pure store at the end, right? And using this we fix the problem. Okay, so that's it, right? We've written the interpreter. It wasn't that hard. Unfortunately, we had that, we tried using a new type here, but that turned out to make the code slightly more complicated. I think in the end, like when we write our production ready code, we will go back to having a new type here, and then we will write a few like simpler, better functions specifically for our store, and that will be fine. But for now, when we're prototyping and we want to get something out there fast, and this is perfectly fine to do. Right, so we are able to interpret our commands quite nicely. Okay, so now we have to parse from string to command, right? So that means we need to write a single function called parse from string to commands. Literally, that's all we need to do, right? And I guess, well, we'll see in a minute that it will not quite work like this, but we'll see, right? So we have some input here in the form of string, right? So what did we say? Well, we said we have a few options here, right? So let's see. We can use this sort of guard syntax, right? Where we could say, okay, if input is equals to exit, then I guess we can return the command exit, right? That's pretty trivial, right? And again, if input equals to dump, then the command is dump, And we're done with these two commands. That was very, very easy and simple to do, right? Okay, so we have like, what other cases do we have? Well, we have the cases where the string starts with get and then has a key, and then starts with put and has a key and a value, which kind of requires some, like, we can't really do equals, right? Maybe we can have a starts with or something like that, but yeah, I'm not sure. Maybe we can do that. So let's see. Do we have a start with function? We have, right? We can check this and we get a Boolean result, but I'm not sure we really need it. I don't think it brings a lot of value to this, right? So let's maybe do otherwise, right? So if none of those were true, right? So if we're not in exit or dump, then we're rather in put or get, right? So let's see what kind of things can we do here. Okay, so let's actually start by splitting everything in the input by spaces, right? Because we already said that no spaces are allowed, and we use spaces to delimit keywords from inputs, right? So let's do that. So I think we have there exists a split function within Purescript in Purescript string. So we'll have to import that package as well and use this function. So let's start by importing this this type. So let's see, Spago again, and let's add strings. Let's build it again. And of course we'll get the error because we have not finished or completed our function, right? Parse, right? Okay. Right, so we have the split function. So how does split work? So let's write this down here. So we have a split, right? So let's look at this, right? So we have a pattern, and we give it a string, and we get back an array of strings. Okay, so we know that we need to give it some pattern, and let's use like let's keep a like I know a this type hold here, right? So pattern, and we don't really know what this is, but we know we need to pass it input, right? The input, and then this gives us back a list of strings. So I guess we need to pattern match on this, right? And we'll see what things we can do here, right? But for example, if it's nil, then we know that this is an error, so we're not sure what to do here. Maybe we just type exit here, just as placeholders, right? We will not actually return exit in these cases, but just as placeholders, just for us to figure out. Wait, is it an array? Okay, it's an array. So I guess we have this sort of. Let's just do this for now. Okay, I guess we could just do this. So that's fine. Okay, so let's look at this pattern, right? So whole pattern was inferred in the following inputs. Actually, I wonder if we can get a better error message than that. So let's see. Let's see if we can get a better message. Yeah, okay. This I guess it doesn't have any suggestions for us, but we can definitely figure this out, right? So pattern is a new type over string, right? So you can just type pattern and then string and then some string, right? So you can do pattern. It should be, where is pattern defined? I think it's this one in data string. Okay, and then we do an this thing, and then this should compile. Yep, it does. Okay. So then we have an array, right? So how do we pattern match an arrays? Well, I guess the easiest way would be I think we can do something like this, right? So if you have get, and then the second array is something like some key, then we can do something like get key, right? And otherwise, if this first one is put and then we have key and value, then we can do put key value, right? And otherwise the result is, what do we do here? Well, let's do exit for now and make sure this compiles, and it does, and it definitely works. So then what do we do in this case, right? So in all other cases than this, right? Because we've covered like 4 cases, which are the ones that we care about, but then what happens in every other case? Well, the problem is we can't really create a command if we don't have anything meaningful, right? And we don't really, like, if the user mistypes exit and adds an extra t, or like, I don't know, mistypes get and like doubles the t, we don't want the application to exit, right? Or the interpreter to run a random or arbitrary command. We would rather have something like it say that unknown command or error or something, right? So in order to solve this, we usually use the maybe type. So the maybe type is a type that which allows us to express that commands may or may not exist, right? And this means that whenever we actually have a command, we need to wrap it with just, right? It means, okay, a command exists, right? And when we don't have one, we just return nothing, right? We're saying, okay, there's no command to return. And then this actually is very usual, relatively usual type for a parser, right? Because like a string might not be something that we can represent with our language or our commands or whatever we're trying to parse. Okay, so that's the parsing part. So yeah, we now have a parser. Right. So the last thing that we are left with is doing the console input and output. We already have output, right, with console with the log. So what we need to do is we need to do input. And in order to do inputs, we need to use this readline library. So let's look for it. So we also need to add this library here. So it's node-readline. So let's say Spago. I think this is the last library we will be needing for now. So it's node-readline. Let me double check. Yep, that's the name. Okay, so let's do the Spago install and Spago build for one last time. Okay. And then readme. Okay. So, okay, what do we need to do now? Well, we kind of need to do some sort of loop, right, where we read from console and then write and so on, right? So if we look at the readline documentation, we will find that we have this question function here, which takes a string, which is something that we present the user with, and then this is a handler, is what we call it, right? Given a string, we perform an effect. And then we have this like interface, which is the what should we call this? It's something that's very specific to readline, and we will not really care about this very much. And the result is an effect unit. Okay, interesting. So let's see what can we, well, like what sort of thing can we do here actually? So let's see. Well, I guess we can just start using question, right? So we can do question, and then we could do like maybe some prompt here, right? Let's use a lambda prompt because that's always more fun to do. Although this has nothing to do with lambdas, but that's still fun to do. And then okay, this is where things get tricky, right? So we need to pass in a function, which is from string to effect unit. The problem here is that we were actually hoping to see a function where this is from effect to A and the result is an A, right? But this is not the case because we can't really do this. So I think there is one other library which is an F version of this. So let's have a look at its API and see if that would help us. Because, okay, let me try to explain the problem slightly better. So the problem is that, actually, let me go back to this. To the type signature for question. Right, so what we basically need to do is we need to fit into this shape our interpreter shape, which is kind of like parsing into a command, and then after we parse into a command, we kind of need to do something from command. So that kind of works, right? Because we go from string to sometimes command, and then from command to an effect store. But we also need to somehow capture this thing, right, from store to effect store rather than effect unit. But this library expects something from string to effect unit, right? So let's see, maybe the F version has a better. So let's see, do we have a question here? Right, and return the response. Yeah, see, so this thing looks a lot better because it allows us to do to work from string to string, right, rather than forcing us into a callback situation. So this will probably be a lot easier to work with. So I guess we'll be using this instead. So I guess I lied, right? We will not be using this thing. And let's remove this that we're not using anymore. Let's replace readline with readline F instead. I think that means we also need to use the F library as well. Oops, I did not mean to do that. The F library. In order to go from effect to F. So F is asynchronous effects, right? And I guess we need to do a launch F, right? And then everything is fine. But we still need this library here. Okay, so let's hopefully for the last time, this time, do a spago install. Okay, so apparently readline F is not in our list of packages, so we need to add it manually, which is fine. Okay, so let's do that. So let's see, we need to do an addition, and I can never remember how to do that, so we just copy it from the example, paste it here, and then rename things, right? So it's node readline F as the name, and then the dependencies, well, usually just grab everything from pursuit, hit copy, and then paste them here, and then we just need to do some massaging of so let's see, we need to do something like this. So we need to replace Purescript. Well, we need to escape the parentheses, so anything here up to space, and then everything with the first replace group, but then we need to parenthesize it, to put it in this sort of thing, and we need to add a comma at the beginning, and I think the rest we can do manually, so this is fine. Maybe we can also do this like so. Okay, cool. And then I guess the one thing we need to do is replace this like so, and that's it. Okay, and then we need to do the proper repository here, so let's copy the location. Okay, and then the version is actually 030, I guess. And we can hope that this is an omission and not something that was removed because it doesn't build. So let's see if that's the case. So let's try installing and building. And it seems like it's building correctly. Yep. Excellent. Okay. So now I guess we need to do a launch F. And I can never remember what's the difference. Okay, discarding. We don't care about the fiber, so we do a launch F. And then do, right? I don't think we need, oops, we need this. Net. So I think this should compile now. Yep. So, okay, now we have question, and we need a monad F version of question where we do something like the lambda input that we were going to do. So let's look at question again. And then we need to give it an interface, and I think the interface was being created using this, right? We can just copy paste. So create console interface, not no completion. So well, I guess we can do this instead, and we can say interface is create console interface and no completion. And then we can do launch F where we do this over the interface, and then we can do response is this. And so let's just do a one command, which doesn't really help us much, but let's just see that we can do a dump or a something, whatever. Okay, so we have this, right? So what do we do next? Well, we need to do parse, right? So we can do let command equals to parse response, right? And then command is a maybe, right? So we need to do case command of, right? And then this is a maybe command, so let's do mc, right? M command of nothing. So if it's nothing, then we need to like maybe log a could not parse command, and if it's some command C, then we should do some sort of interpret command. Interpret? I think it's just interpret, where we give it a command, so command and a store, and then we get back a store, right? So I guess that means we need to create a store, right? So let's define a store here. And then let's initialize it with a nil value because it's yeah, it's an empty store by default. So we do this sort of thing, and then the problem is the result. So let's compile, and you'll see the compiler here. So this again returns a unit. This returns a store, right? A list of tuple string. The thing is we're not really using the result here, so I guess we could just discard it, right? So if you want to discard something, you just do this, right? And that should be okay. And then okay, are we importing the wrong question? I don't think we are. So let's see, what are we doing wrong? Question wants a string and interface and gives back an M string where M is a monad F. What's the error here? Oh, okay, get it. So interpret is something that runs in F, right? So we need to do lift effect. No, I think it's lift F. So how do we go from effect to F actually? I always forget this. So let's look at monad F and how do we lift an effect? Okay, so how do we lift an effect into F? Make, launch, run, fork, suspend, attempt, delay, join, effect, catch, try. There should definitely be a way to do this. Oh, it's just leave the fact, I guess. Oh, well, and we need to parenthesize this. Okay. This is really confusing here. Oh, what log is this? Is it the... okay, so we need this class, I think. Okay, let's find the proper log, which works on monad effect instead. And that's it, right? So because of the log, the infer type here was effect. So once we fixed that, we got it compiled. Okay, so let's see if it actually works. Right, so let's try running it. So we're getting the prompt, so let's try dump first. Let's try exit first. Right, so we didn't get an error. Let's try exit with like double T's and see if we get the error. Okay, so it could not parse the command. So when it cannot parse the command, what happens? So could not parse the command. Oh, and then I guess the f never completes. Okay, I mean, you can just exit out of it manually. Once we start looping, then that should probably be fixed. So what happens if we do dump? Well, it just crashes. That's interesting. I wonder why that is. So what does dump do? So dump is traverse of log over get data store, and then get data for an empty store gives us a nil value. Oh yeah, it doesn't print anything. Okay, it doesn't actually crash. It just executes it, but it doesn't exit. Same thing as before. Actually, and in order to convince ourselves that that is the case, and I think we could just, at the end of this, we could do exit. Not exit. What did we call when we wanted to exit? Was it actually exit? Yeah, it's actually exit. Okay, so this is an effect, so I need to do lift effect, exit of 0 again, right? So let's try doing this same thing again. So let's mistype something, and yeah, could not parse, and we exit, right? And then let's do dump, and then we dump, but there's nothing to dump, so we exit. So let's do a put 1, 2. But then, right, it doesn't print anything, right? And then let's do get 2. And then no key found, obviously, because there's nothing interesting we can do with a single command, right? So let's try to loop this thing, right? And just because I want to show you that we have some, like some modules have quite reasonable documentation, I think or at least examples. I think I glanced the readline af docs have actually, I do have actually an example with looping, so let's see if we can use some of that, right? So let's see, we have loop interface. So what's loop? So loop takes an interface, and then, well, maybe this is, okay, so this is a loop. So what does this do? Prompt, ask a question, lift, prompt interface. Okay, so where is the looping part? Oh, so at the end it's just a recursive call at the end. Okay, so the question is, what do you want to loop? Where we want to loop this part, right? So what if instead of here we do loop, well, we don't really want to loop store, right? Because we kind of want to feed the store into the next iteration. Well, yeah, actually we do want. So we want loop store, that's fine. Okay, and then we do where here, and then we say, okay, what's loop? Well, loop is a something that takes a store and gives us an f store back. And I think in order for this to work, we need to do something like actually do and then pure unit at the end or something. Okay, then return f store, right? So what do you want to do here is kind of something like, or actually at the end we probably want to do this thing, right? Just the exit when we're done with the loop. I think that's perfectly reasonable. Okay, so we do this sort of thing where we do response equals to this, then we do a command where we parse the response. If it's nothing, then we have to do kind of two things, right? We need to log this, and then we need to call loop with the same store that we got, right? So let's see, loop store equals to this, right? Well, to a do block. Right, so if we could not find a, let's remove this from here. So if we could not find the command, we just print that we can't, and then we try again, right? Okay, and if we do find a command, then we get the new store from here, right? So we just basically, instead of doing this thing, we just return the new command, the new store. And I guess we have not imported the f type, so we just need to import it. Right, and we also need to pass the interface to this thing, so we need to do loop store store and interface, I guess. It would probably be more interesting to have interface first. Okay. Okay, so now we also have the interface, but I think the thing is we also need to loop here, right? So this is the new store, and then we want to do loop over the interface and store prime. And again, this is the regular store, but we also do interface here. I think that should be all. Oh yeah, and I think we needed to discard the result here. There we go. Okay, so I think we should be able to loop over this now. So let's see if that works. So let's do a dump just to make sure we have an empty database, and we do. Let's do a put at key 1 value hello, and then let's do a new dump, and there we go. One has like value 1 has hello. Let's do get 1, and there we go, we have hello at value 1. Let's put 2 and the world. Let's dump get 1, get 2. Let's put into 2 world, and let's add a bang at the end. Let's do a dump, and that definitely works, right? Of course, these are not order, right? So if we were to put 0, which is whatever high, right, 0 would be at the end, right? Because we always append at the end and we never sort them, right? It's just not something that we care about right now. And then I guess we could just exit, and exit should take us away. There we go. So yeah, that's I think that's everything we set out to build initially. So we can also do console read in out and looping, and of course we should have probably added looping as a separate thing there, because it took us about as much as all of the other things. But hey, that's how it goes with estimations, right? You always forget something. Yeah, so this is the whole everything that you need to do to build a like trivial in-memory database. It's not even 100 lines of code, including import and all of the empty spaces and empty lines and so on. So I think it's pretty neat, and I think we will be doing upcoming videos where we add functionalities to this, right? Because there's a lot of things we can improve here, right? The type safety is not great. We can only store strings. We cannot store spaces. The error reporting is not great. Like, for example, well, actually, the error reporting is reasonable now in some way, right? Because if we do get 5, we know that there's no key found, and then we know this is a parse error, right? Although, like, there's no distinction between get space and nothing else. Well, I mean, yeah, it kind of is, because it's an empty key, I guess, so that's also fine. But this should basically be missing key, not no key found, because it's the same error as this, right? And I guess put is, again, put 1 should be expected value, could not parse command or something, right? So there's a lot of improvement we can do to parsing. There's a lot of improvement we could do to our code to make it easier to reason about. We can also add networking instead of doing console, and a lot of other features. But for now, I think I think there's, okay, let's try, let's see how hard is it to add one more command to this. Let's do delete, right? So let's do, so the way I usually do, so, okay, when you start with some new code, it's kind of, you don't always know where to start, right? But usually when I modify code, when I want to change code, I usually start with the like type, right? And I kind of also started with the type when I started from scratch. So I guess I always start with the type. And the reason is, so let's see, when I do this, and let's actually, let me try to showcase this better. So let's stop looking at this thing, the plan. So we have no clear plan now. We just, so I will start PSCID here, which is basically a program which allows me to track errors, right? And you will see the errors on the right hand side of the screen, right? So when I save this file, you'll see that this ran and is checking my code, and then when you see the else, it means that it's a-okay, no compile errors, right? And just to prove it, let's add like a random letter here, and then you'll say unable to parse module, because hey, what's this a here, right? And as soon as we remove it and save the file again, then you get the happy owls again. Okay, so the way I usually do it is I change the type and I do delete, and then what do we delete? Well, a key, right? So it's similar to get, but it's a delete command, right? And then as soon as I save this, you'll see an error, right? So this says, okay, we are not covering all cases here, right? You're kind of forgetting to cover a case, which usually means you have a bug, right? And that's perfectly correct, right? I should be handling delete in my interpreter, right? So, I mean, let's handle it. So if we want to delete some key, right? What do we do? Well, we just delete the key, right? So it's remove, or let's just call it delete, right? Delete key over store, right? And then this is a pure thing, right? And then we save this, and then, okay, well, what is delete? I don't know what delete is, and that's exactly what we're expecting to see. So let's write a delete function. So it's a function from string, which is the key, to store, which is the input store, to store, which is the output store, right? Because we're changing the store. So we have delete key and store, and well, can you guess what we're about to do now? Of course, we're going to pattern match over store, right? So if we have an empty list, then the result is empty, and if we have a database where we have a tuple with a current key, and so we don't even care what value is there, then what do we do? Well, again, if current key is the same as key, then we want to so if we found the thing that we want to delete, then we are basically done, right? So you have a rest here, so then we just return the rest and we're done, right? We removed the thing that we were trying to remove, and we stop. If we have not yet found it, then we need to keep this, right? So this is, let's say, the current head of this, right? So else we want to const the head with delete key or of rest, right? So we kind of want to keep looking in the rest of the database, but we know that we have to keep the current thing because it's not what we're trying to remove, right? Oh, and then we need to also pass the key recursively. Okay, so this is fine. This has worked and this has successfully compiled. But as you'll see here, because our parser is not great, and I think it's also pretty hard to do a parser that will give you a type error here. We kind of have to remember that, okay, delete is also a command. We need to parse the command, right? So unfortunately, we don't get an error here, right? So we need to add a delete key here, which interprets to just let me replace this, right? Because we have not used this operator here. So this just replaces parentheses, but hey, we can just use parentheses just as well. Right, so I think that's all we need to do to remove keys. So let's test it out. Let's rebuild and run it again, right? So it's building, build succeeded. So let's say put 1 and hello, put 2 and world, put 3 and delete me. Right, and let's do a dump, right? So we have hello world and delete me, right? So we do delete 3 and then dump again, and it's gone, right? And we do delete delete 1 and then dump again, and it's gone, right? So we can do get 1 or get 3, and they're no longer there, and then we can do delete 3 again, but well, we don't have an error here, right? So when you're trying to delete something that doesn't exist, we don't do an error in this case, right? So you can delete 3 as many times as you want, but when you do dump, it's just not there, right? Nothing happens. It doesn't randomly delete something else. Right, so that's pretty much it. We won't be doing any other features right now because I just want to showcase how we can add one more command here, right? So yeah, next time we'll see. We'll probably improve the well, there's not a lot of duplication here, right? Because a lot of these functions do a pattern match on the store. Right, let me rename this to store as well, right? A pattern match on the store, and then do an if key equals key. So all of these operations seem very, very, very similar, which probably means that we can remove a lot of duplication if we refactor this code a bit. And it will be interesting to see how easy it is to refactor Purescript code, to write parsers and so on. But that's for next time. So thank you for watching, and see you next time.